This is a 3D printed TARPN node enclosure supporting power supplies, the Raspberry Pi, and 4 FM transceivers. The unit is constructed using parts that are somewhat modular and could create a bigger or smaller cabinet depending on the needs of the TARPN node. This particular assembly holds equipment for 4 packet links on the top 4 levels and has the 5th level supporting the Raspberry Pi, control panel, and power supplies. Each radio level is equipped with a Nino TNC whose drawer slides out to provide access to the mode and signal switches, as well as to the TNC's connector to the radio and to the Raspberry Pi. Further access to the interior of the node enclosure is available via magnetically clasped flip-down panels. The panel is big enough to reach in and adjust wiring and connectors to assist in diagnosis or replacement of parts in the node box. These flip-down panels are strategically located for convenient access to various parts of the node components. The bottom level of the enclosure includes a control panel wired to the Raspberry Pi to provide status, battery backup management, and Linux reboot or shutdown controls. The Raspberry Pi is mounted on the control panel's 3D printed object, which extends towards the back of the enclosure. Using the flip-down panels, we can access power, video, USB connectors, and the micro SD card on the Raspberry Pi. The Ethernet connection is extended out for easy access. The gray ribbon cable connects to the back of the green control panel in the front of the enclosure. Moving to the back of the enclosure, we find a bulkhead connector for each of the radios. This unit is outfit with 4 end connectors. There is a panel supporting a 2 amp SLA battery for the digital section's UPS. Replacement of the battery is trivial, requiring unscrewing 3 machine screws to remove the battery mount. Using a flip-down panel, we can access the battery terminals. Also visible inside is the top of the HP DPS 12-volt power supply. The HP power supply is located behind 2 panels on the back of the enclosure, and it slides in and latches to a panel on the right side of the enclosure. The surplus HP server power supply is made to slide in and latch into a server enclosure. The 6-position automotive blade fuse box is mounted externally to the enclosure for ease of access. The fuse box distributes 12 volts to the input of the digital section and SLA battery charging circuit, as well as power for the 4 radios. Small replaceable frequency and neighbor identification cards screw into the front of each section to help the operators of the node with system diagnostics. They also aid in recognition of the site from photographs or when the enclosure is off-site for some purpose. The enclosure uses 213 M3 screws and square nuts and 26 M2.5 screws and hex nuts. The handle object is printed in 2 colors, but is a single PETG unit. When screwed into the enclosure as shown, a single handle can easily support the node box. 2 handles make the enclosure relatively easy to transport. The design of this enclosure is scalable. It can be constructed with as few as 3 layers, so 2 radios. This particular fuse box can only handle wiring for 5 radios hooked up the way I did, but the limit for scaling, for me, would be the weight of the equipment with regard to convenient transport. The top structure is designed to provide ventilation and protect against falling objects. However, it is capable of supporting a linear power supply. If you're going to test it over 40 pounds, please test carefully as the shards of an exploding PETG piece could be dangerous.